Next, we have Dave Caudle from Chemlmage Corporation coming up. He's going to speak a little bit about layered threat detection and entry control points, integrating new technologies. Dave leads the effort to connect emerging chemical imaging technologies with the needs of defense and security markets. Dave has 12 years of experience as a military officer in Army infantry and special ops, fighting in the global war on terror. After leaving the military, Dave advises his Department of Defense, Department of Homeland Security on countering weapons of mass destruction. And Dave is an expert on chemical, biological, and explosive threats and protecting critical infrastructure. So with that, we'd like to welcome Dave to the conference here. Welcome.
Good morning.
So we can hear you. So whenever you are ready, are you going to share, or do you need me to share your presentation?
I'll share it. Thank you.
Okay.
So you can see me and you can hear me, correct?
Yes, sir.
All right. Thank you for the opportunity. So good morning, all. I'm Dave Caudle. It's a pleasure to be here on behalf of Chemlmage Corporation. If you're unfamiliar with us, we're an industry leader in threat detection technology. The topic is layered threat detection and control points, how you utilize and integrate new technology into existing protocols. I'll go ahead and get started.
Dave, you're a little muffled. I don't know if your mic is.
Sure, I'll turn up the volume or I'll speak up. How's that?
Yeah, better. Thank you.
All right, thank you. Okay, so just a quick introduction of myself. As previously stated, my background is 12 years as an Army officer and 4 years in threat detection technology. This slide really just says that I've been around the world in a lot of high-risk places, protecting critical infrastructure and assets that are important to the United States government. All right, so the motivation for this talk today, of all the threats and the risks that this community faces, why are we talking specifically about explosives? What I've experienced internationally is that oil and gas infrastructure uniquely represents an attractive target to extremists and to non-state actors. By attacking oil and gas infrastructure, the attacker can accomplish an amplification of explosive damage, energy supply interruptions, significant and expensive harm to businesses, including power generation and manufacturing. In short, explosives typically make a statement. So let's not think about this as just some far away, destabilized country. Your infrastructure in this country has been plotted against many times, listed on the left-hand side of the slide. Fortunately unsuccessfully in the U.S., but also successfully in North America, in British Columbia and Canada. There have been successful explosive attacks on oil and gas infrastructure. So of all of the topics that we could talk about in the security realm, cyber and drones and so on and so forth, I will tell you from personal experience, this is really the topic that would garner the greatest risk in my mind if I worked in this community. Go ahead and build a slide. All right, start with a doctrinal reference here, just so you understand this is not just my thoughts. What I'm going to present to you today is really based in the doctrine of the Department of Homeland Security. For your reference, the DHS publishes a very helpful guide called the Security and Resilience Guide for Counter IED. This document outlines 5 goals in countering explosive threats. Obviously, we don't have time to cover them all, so we're going to focus on goals 4 and 5, where we can really take the most action. I'd encourage everyone that's interested to read the document and familiarize yourself with the other goals. But we're going to focus on 4 and 5 today, because those are really where we can have the most impact. The link to this document is in the bottom right-hand side of the screen. I believe you'll get a copy of these slides after the presentations today. All right, in the realm of explosive threats, there are a lot of ways that an attacker can get explosive threats and use them against your infrastructure. However, the chart on the left-hand side really outlines why I want to focus on vehicle-borne explosive threats. So the acronym there, VBIED, a vehicle-borne improvised explosive device. It has the potential for a much greater explosive yield. So what a human being can carry or sneak in, usually inside of a suitcase, a backpack, strapped to a bicycle, those sorts of applications, that's a relatively small explosive yield. So that amount of explosive, we're using TNT as a reference here, 30 pounds is about what we see for personnel-borne explosive devices. So that device really has to get to the exact right location. That attacker has to have some unique knowledge and understanding of where to put that device. It has to get through many layers of security to place that device. The reason why we typically talk about vehicle-borne IEDs is most of the incidences that we've seen internationally that have caused significant failure of critical infrastructure have been vehicle-borne. This chart on the left-hand side shows you, just the standoff distance and the potential for lethal injuries and for damage to infrastructure that can be caused by a vehicle-borne explosive device that's only 3,000 pounds, and how much more yield they get than a personnel-borne. And this chart on the right, this 3,000 pounds of TNT that's causing significant damage and fatalities up to 300 feet away, that's really only at the full-size sedan, passenger van, cargo van type of weight. We're talking about 3,000 pounds of bang. If you escalate that to, a small box van, or even worst case, a semi-trailer, then you're up in the area of 10,000 pounds, 60,000 pounds of achievable explosive yield. So I'm going to attempt to tailor my comments today primarily on the worst case scenario, which is a whole bunch of explosive material inside of a vehicle. It's a pretty difficult problem. It has been for us for years. All right, so let's talk about the disrupting IED incidents and really the stages for how this happens. So any would-be assailant using explosives to cause harm to your infrastructure, they have to go through some planning and resource stage. They have to select a target, they have to scale the site, they have to acquire the materials, they have to construct the device, and they're exposed to the community while they're typically taking these steps. So in phase one, best case here for us trying to protect our infrastructure is that the intelligence community, law enforcement, they're going to share information with us. Hopefully the public, to see something, say something has rung true, and we have some prior warning of an explosive attack, and law enforcement can work with you to attempt to interdict that attack or help you temporarily harden your infrastructure before that attack comes. That happens sometimes. Unfortunately, it doesn't happen every time. So we still have to be prepared for if the assailant gets to step number 2, which is delivery of the device, the stage that we call attack. So in order to detonate that improvised explosive device, that explosive device in general, or leave it somewhere for future use, that perpetrator has to gain access to the target site to deliver that explosive weapon. And the counter to this, I think I've seen is pretty common in you all's industry, some general hardening and some maximizing of standoff distance. I've seen some bollards and some checkpoints. I've seen some strong security gates. This, generally is an attempt to prevent that vehicle, that explosive device from gaining access to the facility that houses critical infrastructure. So what I've seen is usually when these installations are built, I have seen usually a pretty good security perimeter. I've usually seen a pretty good buffer zone, number 2 there, between the outer fence and the most critical components or critical infrastructure, which is great, and that prevents the target or the assailant from coming from any direction. However, in this process, the weakest point is that entry control point at the top here. And that's because most of the successful explosive attacks, especially these successful vehicle-borne high-yield explosive attacks, were not driving through some portion of the security perimeter. There were allowed access at the primary entry point. So this weakness is not something that barriers can fix. In order to do, as just a function of doing business, you have to let things come and go through your entry control point. So the only way to mitigate this is really some form of screening and some form of detection for those vehicles that are entering and exiting through your ECP. So how do we identify which vehicle presents a threat is really the question that we're trying to answer. So here are some current operational standards, sort of the state of the art in the industry. Canines are very popular. Everybody loves dogs. This is sort of the industry gold standard. They're proven to be reliable. However, it does typically have a significant recurring cost, and the dogs have to get right on top of the target. They can only work so many hours. In order for that dog's nose to be effective, it's really got to be, unfortunately, it's really got to be within the blast radius of even a small explosive device to be effective. You've also got handheld explosive detectors that are common in these entry control points, and those handheld explosive detectors are really good for sort of confirming the presence of something if there's something that's suspicious. So you already have to have identified there's something that's not right. There's some residue or there's some material present that you want to confirm is an illicit material, and then you can use that handheld explosive detector to do that confirmation. However, it's not a broad screening tool. That detector can't tell you if explosives are present in that vehicle or not. Next, you have X-ray scanners, and those are pretty accurate with the right trained personnel. However, X-ray it's not giving you any molecular information of what's inside that vehicle. It's looking for densities, and there are a lot of, you really need some trained and qualified people to discriminate between what's a density that's commensurate with explosives and what's a density that's commensurate with other materials that may be arriving on site anyway. These things are not typically very portable, and they're typically very expensive. Lastly, and I think most commonly what we see in most entry control points, not just in the oil and gas community, but also critical infrastructure all across the United States, is physical search. So we have a security guard or a couple of security guards, and they are physically searching the vehicle. So not only does that require a pretty significant amount of training burden for those users, but again, that user is right on top of what we are treating as a potentially explosive device or explosive vehicle, which is not optimal. And if they're, the mirrors are great. I think you typically see that on the news. But what they're doing when they're searching around with those mirrors is they're looking for any device that's attached to the bottom of the vehicle. Those mirrors really don't do anything for you if that explosive device is embedded and concealed in the trunk, in the seats, in the back seat, what have you. Okay, so this chart is really, this Harvey Balls chart of the strengths and weaknesses of each approach is really just to outline and identify that we know this problem very well. I know this problem very well, and I will tell you it's a very challenging problem. And if there was a silver bullet out there that I could recommend that will solve your problem wholly and completely, I would recommend that, and that is absolutely not the case. So every site that I visit and survey that I do and recommendations that I make, it's very often, if not always, some version of multiple techniques, multiple approaches, and multiple technologies to get the best of each. X-ray provides a lot of value. Canines provide a lot of value. There's nothing on this list that can solve this problem completely. I do want to add, I want to transition to optical imaging, which is on the bottom of this chart. Obviously, we provide optical imaging as a company. It's becoming more prevalent in the defense and security space or in the commercial market space, but it's been used in the DoD for 10, 20 years now for problems like this. It is also not perfect. However, it does provide you a lot of additional capability when it comes to ECP security. All right, so let's talk about how our technology works, how molecular chemical imaging works. It's a mouthful. So spectroscopy is the study of the interaction between matter and electromagnetic radiation as a function of the wavelength or frequency of that radiation. So in molecular chemical imaging, we're using light to determine a chemical fingerprint and match it against a library of spectral fingerprints. So I'm sure that this community is familiar with electro-optical infrared sensors that are measuring heat. I think you all use a lot of these sensors sort of in the methane leak detection space, that sort of thing. So they're looking at contrast with the heat of the material escaping and the background. So we're looking for that same sort of contrast, but we're not in the part of the spectrum that's relevant to heat. We're in the part of the spectrum that's relevant to the chemistry of those materials. So we can measure the way that the light interacts with matter, and then we can make a very, very good guess as to what material that is and whether or not it presents a threat. The Department of Defense and the commercial sectors have used this type of technology for many, many applications, all the way from intelligence, surveillance, and reconnaissance, from drones for the Department of Defense, all the way down to surgery visualization when surgeons are operating on a tumor. My company specifically uses this for three things right now in the commercial space. We use it for advanced analytical, biomedical, and surgical life sciences applications. So by measuring this sort of chemistry, we can understand where a tumor margin stops and a person begins. We can highlight critical structures for the surgeon so he doesn't cut them. We use it for the detection of illicit substances like drugs coming in through the mail into prison facilities. You can see the example of our product. This is what the user sees. On the left is this child's colored image, but on the right, what our machine sees is it's embedded with illicit substances that's being attempted to be smuggled into the facility. And then to transition to the topic at hand, on the right, we use it for standoff detection of chemical and explosive threats. A lot of problems for the DoD, but we also solve these problems commercially for security customers as well. So where did this come from? When our country was fighting two wars on two fronts in the Middle East, the enemy's chosen weapon system was IEDs, and vehicle-borne IEDs were really our biggest casualty producer. The United States government invested a lot in us and other companies to come up with a solution to this. So we spent years perfecting technologies that are intended to be placed at ECPs and take these measurements at the outside of a vehicle that's attempting to gain entry into one of our outposts. So on the right, you'll see a detection example. What the user sees is that pickup truck with those barrels in the back, and that grayscale image on the bottom shows the contamination on the outside of that container. It's indicative of what's on the inside of that container. So through many years of this technology being used in the Middle East, we had many interdictions of explosive material, just based on the fact that when you load this explosive material into a vehicle or into a container, it's likely that you are going to leave some trace residue amount of material on the outside of the container that can be measured when that vehicle pulls into the ECP. So when we brought those sensors back from the global war on terror, there was a high demand in this country for explosive device screening, given the state of affairs in the world right now. So that demand really created us to go down the path of smaller, less hardened, cheaper, size, weight, and power reduced sensors that were available to law enforcement, first responder type community. So we took that DoD technology that was helping keep our soldiers safe on combat outposts downrange, and we miniaturized it and made it accessible to the public. We both have sold those sensors and have been contracted to employ them ourselves at checkpoints and events. The Indianapolis 500, the US Open is used as an example here, where we're screening vehicles with these sensors and informing the decision of local law enforcement or of their security professionals to allow entrance or to deny entrance to these vehicles. Just to give you an impression of what the user sees when they use one of these devices, unfortunately, I can't share any of the live true positive detections from downrange. That's still sensitive information. However, I can show you an example of what it would look like. The US Open, fortunately, we did not have any incidents. We did not have any live explosive material that was attempted to be smuggled into the US Open. But the local law enforcement obviously wanted to test our system, so they drove their own car through, having put an explosive stimulant, ammonium nitrate and fuel oil, on the door handle, and that's what the detection looks like on the right. That's what the user sees, is a false color overlay highlighting there's a problem. There's a substance present here that is indicative of an explosive device inside the vehicle. So what do we typically recommend? We go to these sites. I understand the total layered approach, the current state of affairs, the unique problems of these entry control points at every site, and then we make recommendations. And these recommendations are usually some combination of what you see here. You want a passive strategy that's going to measure, some sort of passive strategy that's going to measure every vehicle that's attempting to gain entry, where you don't have to do a physical search on every vehicle, which is both time consuming, may involve working dogs and people too close to potential devices and so forth. You want something passive on the left-hand side here. You want an optical imaging, license plate identification technology to match it to suspicious stolen vehicles, that sort of thing. Something passive that's measuring every vehicle, and then some way to take another step, some way to confirm. If you get an alarm from one of the first couple of steps, you want some trained user, canine, or piece of handheld equipment that can, in fact, confirm that you have a problem so that you can take the appropriate action. These technologies are extremely good and have a high probability of detection and a low probability of false alarm rate, but still you're going to want some method of confirmation before you take the step of segregating that vehicle. Okay, so I would be remiss in this opportunity if I didn't say that obviously my company sells both this technology commercially and provides it as a service for particular events and for high risk times. So to sort of close this out here, hyperspectral imaging can expand your security perimeter, be a valuable layer in counter-explosive security operations. Solutions are commercially available. There's some requirements listed there about what your expectations of these devices are at the moment. And on the right-hand side here for fun, you can see us leveraging these technologies to screen vehicles for explosives before entry near the Pittsburgh Steelers Stadium, downtown Pittsburgh. So I want to leave plenty of time for any questions, and I'll open up the floor.
Thank you, Dave. Yeah, if anyone has questions, you can use the chat function, or you can just unmute and state your question verbally. I guess I'll start it off. I mean, what sort of interest are you seeing from some of the oil and gas or midstream operators in the region here, or even nationally? And is there a type of facility that they're looking to protect more so than others?
Yeah, absolutely. So to answer those questions in turn, the answer to the former question about interest, the international interest is significant, in oil and gas and otherwise. We're very fortunate in this country that explosive attacks are often planned, but not commonly carried out here. And in some of the places where we sell these instruments and work with local officials or companies, they are pretty frequent. So I will tell you that I am not articulate when it comes to oil and gas infrastructure. I'm learning slowly, but I want to say that there are processing centers, distribution centers, places where these resources are being transferred or distributed seem to be the focus of applying technologies to screen for these threats. Right. I think that my international customers, for the most part, understand that they can't protect everything all the time. They can't protect every mile of pipeline. That they have to accept risk somewhere. So they typically are looking to make their investments at their most critical, most expensive, and the places that have the highest potential for catastrophe, if that makes sense.
Mm-hmm. Thanks. We have a question from Eric Brink. How often does optical imaging have false positives? Sure.
Great question. So the short answer is it depends on a variety of things. The target material, the background, the environmental conditions. But if you've optimized the standoff range from the sensor to the vehicle, and by the way, the user doesn't have to be right on, doesn't have to be next to the sensor. The user can be a long ways back operating it remotely. But if you've got the sensor at an optimal standoff range, your probability of detection is going to be over 90, over 95%, and your probability of false alarm is going to be under 5.
And follow-up question looks like, does the technology require someone to, looks like you saw that one. Does it require someone to be stationed near it? I think you answered that.
Yeah. So just to pull that thread a little further, because it's a really important point. Most of these things that we're recommending, or most of these things that are really common in the ECP screening security mission, as I mentioned, require somebody to get really, really close to the vehicle. And this is standoff detection in the sense that the sensor doesn't have to come into contact with the material, but it's also standoff in the sense that you can have the user standoff as far as you have an Ethernet port available for, right? So typically when these sensors are in place at these ECPs, the users are in a command center that is hundreds of meters, in some cases 1,000 meters, removed from the sensor, operated remotely.
Yeah, I was going to ask that question. If some of these facilities, obviously valve sets or pipeline metering stations and things are obviously long distances away. You had a wired system there in some of your presentation slides. Are there wireless as well? And what are some of the, I guess?
There are. We have come up with solutions, principally Customs and Border Protection, in an event that we attended in San Ysidro, that are RF based, or getting the data from the sensor to the user is a solved problem, and is really a function of what that site believes is their greatest threat. Is it hacking? Is it RF interruption? And that sort of thing. So commercially, what we sell is a package that's meant to be run off of Ethernet because that's the most secure. But we have certainly come up with solutions for customers who wanted to run wirelessly.
Any other questions for Dave on the phone? Any of the participants have other questions? Feel free to unmute and state it verbally if you'd like. Well, Dave, you did such a good job. There are no other questions, looks like.
All right. Well, thank you for the opportunity this morning. I really appreciate it.
Yeah, no problem. Thank you. We really appreciate your time and your expertise in sharing to the group today. We'll give them a couple more minutes, and just if you could stay on just a few more minutes.
Of course.
Otherwise, we're going to have a little bit of a break before our next speaker. So where was this picture taken, Dave?
That was taken in, I believe it was 2009 in southeast Afghanistan, right next to the border of Pakistan. We had a problem with ammonium nitrate intended for use in farm fields and crops. In Pakistan, being smuggled across the border into southeast Afghanistan and being used against our soldier.
Huh. That was the federal building in Oklahoma City. Was that the same?
That was ANFA. That was ammonium nitrate and fuel oil. Yeah. So unfortunately, you could with a couple hours on the internet. And a couple hours on the internet and a local tractor supply or feed store near you, you could create the same effect as Oklahoma City. It's a scary time that we're living in. The materials have always been there. I think it's the proliferation of bomb making knowledge that has really caused the problem. So, a lot of extremist organizations publish their own version of sort of anarchist cookbooks and encourage their followers to reference those cookbooks. And a lot of those cookbooks even go to the specifics of in your area where we are asking you to conduct these operations, this is what's available and this is how you should make it to defeat the local tactics and procedures.
Wow. We may have another chat. I'm sorry. Go back here to the chat.
And Dave, this is Drew Powers. I'm back on the call. I dropped off there for a little bit, but Dave, I'm sorry I missed most of your presentation, but just on behalf of ABGPA, thank you again for taking the time to talk to us and share your expertise with this.
Of course, Drew. We really appreciate the opportunity. Unfortunately in our world, in CBRNE, chemical, biological, radiological, nuclear, and high yield explosive threat detection, the Department of Defense is always interested. It doesn't really come to the forefront of the conversation in the commercial realm or in the, local law enforcement realm until something really bad happens. So as opposed to be reactive, I think that Pete and I both agree that we need to be proactive and at least get the knowledge out there before that inevitable bad day comes. So we appreciate the opportunity.
Well, certainly.